Hey, so I've been building AI agents and agentic AI systems for the past 18 months, and I wanted to quickly share 10 design principles that I found really help when I build those systems. Let's go over them one by one from broad to more specific. So the first tip is to map out the environment in which the agent will be deployed before you start any design or development work. You need to understand how your users will interact with your agent, what kind of quality is expected of the output, what kind of users control are needed, and so on. One thing that could really help here is to think about the mental models you expect your users to have when they are interacting with your agents. I did a whole video about this elsewhere. I'm linking it here so you can look at it after this video. Tip number 2 is to design the agentic AI workflow before you start working on the implementation. Think about the tools and augmentations that your agent needs, what kind of tasks the agent needs to complete, and how to isolate tasks so that they can be assigned to individual agents. Some good papers came out recently on agentic AI system design. I'll link to those in the video description. Okay, so now that you're ready to write your first prompts or the first lines of code, you want to start as simple as possible, only gradually adding complexity while making sure that everything works after each set of changes. This is working from first principle, which holds for software architecture in general, but I found that this is the best way to go about, especially with non-deterministic systems like agentic AI. Tip number 4. For individual agents, context is everything. Make sure you set the instructions in your system prompt in such a way that your agent can perform the assigned task 99% of the time. This is not just about prompt engineering though. I found that the best performing agents need to have the right inputs, the right tools, and the right instructions. Tip number 5 is to build generic tools. I've found that you can build much more powerful systems if you give your agent access to high-level tools that hide away a lot of the complexity from your agent. Having to rely on detailed instructions in your prompts will result in much more brittle systems that are much more maintenance intensive. Plus, once you have generic tools, you can now also give them to other agents. Tip number 6. Recursion is your friend. LLMs by themselves are not problem-solving machines. So one of the most valuable things you can do in your prompt is to specify how the large language model should go about solving the tasks it gets assigned by the system. I found that zero-shot reasoning patterns that usually work best involve a single agent running multiple passes through information gathering and decision making. Examples of these types of patterns include chain of thought reasoning, reasoning plus acting, or reflection. Best practices will change over time and depend on the LLM system that you're using, so it's best to do your own research here. Tip number 7 is to build large language model agnostic systems. Because even though leveraging the reasoning capabilities of large language models is key to building agentic systems, you need to build your systems to be agnostic to the specific large language model. This means being able to switch large language model or large language model provider with minimal pain. To do so, having a standard API wrapper around your large language model calls really helps, as does having a formal way to manage your prompts, because you will need to revise your prompts once you change to a different large language model. If you're building code-based agentic AI systems, frameworks like LangChain or LlamaIndex can help you with this, because they allow you to easily swap out LLM and LLM vendors with minimal changes to their underlying code base. Tip number 8 is to implement proper guardrails. Even though you can rely on your LLM reasoning 98% of the time, you want to make sure your agents don't go off track or follow malicious user instructions. And while most large language model vendors will have content filters implemented, you do need to think about how your agentic AI system could derail and prevent that from happening. This could be as simple as rate limits or setting business rules, or you could go a step beyond and build your own ML classifiers to identify malicious use. Tip number 9 is to optimize operational costs. You can think about setting a spending cap or rate limits to ensure few users don't hog up all your resources. Additionally, but I recommend you go one step further and run projections of upper and lower bounds of usage. That will give you a better idea of which large language models to use where. For example, for some agents you might want to choose a cheaper but less reliable model like GPT-4o Mini, while as other agents that really need to leverage high-level reasoning could benefit from using O1 if they're not using too many tokens. And tip number 10 is to create benchmark datasets. Your system will change over time, and having a standard automated way to evaluate your system performance will really help. Agentic AI systems are highly complex systems, so when you change a large language model, create new tools, you need to make sure the output still aligns with user expectations. And that's all I have for this video. Reach out in the comments below if you have any questions. See you next time.